All right, so we are going to look at the exploration that you did. So obviously you can't cut out and kind of paste in extra cells if you need to do work. So we're going to talk about how to do skips and jumps in a table without having to do what you did with the exploration when you had to cut everything out. So the process goes back to we have to have some information that we know to determine our rate of change. So that means we need to look at the rows that have both an x value and a y value. So in our first table here, all right, you see that we have 4, -4, and then we have 9, 31, and then 13, 59. So we really need to use those three rows to determine our rate of change and then determine if it is a constant rate of change. So I'm going to look at the change from 4 to 9. So we can see that when I go from 4 to 9, I go up by 5. When I go from -4 to 31, I go up by 35. And if I look at that ratio of 35 to 5, I get a ratio of 7 or 7 to 1. So now the question is, am I going to get that same ratio again? So we have to look at another pair of points here, another piece of information to compare to 35 to 5. So I'm going to look at 9 to 13. All right, and when I go from 9 to 13, I go up by 4. And then when I go from 31 to 59, I go up by 28. So now let's look at that ratio. So I have 28 to 4. And 28 to 4 is also 7. So what we see is that we do have a constant rate of change. All right, they do look different, but that goes back to what we know about ratios, right? So even if we have a ratio of 7 to 1, there's an infinite amount of equivalent ratios to that. It could be 14 to 2, 21 to 3, 28 to 4, 35 to 5. So the question is, which of those do I use when I'm working with a table of values? Well, we have to keep a couple of things in mind. One, the numerator in our ratio tells us the change in y. The change in x is represented by the denominator, and that tells us what is happening with the x. So we have the numerator change in y, the denominator change in x. So which of these possible infinite ratios do we use? Well, it all goes back to the jump or the skip in our table. So we're going to need to figure out our change in x. So if I go back to our table here and look at that first change in x, it goes up by 2. Well, what this is telling me that if x goes up by 2, I need y to go up by 14. So I can see that now I have to figure out what number plus 14 is -4, and that number would be -18. Now let's look at our next jump. I go from 4 to 7, which means I go up 3. Well, then that means that if I look at that middle ratio, if my change in x is 3, that means my change in y has to be 21. So -4 plus 21 is 17. Now the next two values for y are already in our table, so this provides us with a self-check. If we have the right rate of change, it should all work out to give us 31 and 59 based on what we are doing. So notice our jump from 7 to 9 is 2, which means we're back to that second ratio, which means our y should increase by 14. So 17 plus 14 is, in fact, 31. Great. All right, 9 to 13 is a jump of 4. So now we're to the fourth ratio up there. So if x goes up by 4, y has to go up by 28. 31 plus 28 is, in fact, 59. So we see that we have those values. So that means we are on the right track. We are doing things correctly. So let's look at our last two changes of x here. We have a change of 3, which means we're back to that middle ratio. We need y to go up by 21, which means 59 plus 21 gives us 80. And our last change of x is 5. So we're to that final ratio, which is 35 to 5. All right, so y needs to go up by 35. 80 plus 35 is 115. All right, so beautiful work there. So what we want to do is take this and apply it to what we did last time. So today's lesson is really the same lesson that we talked about in our previous work, except instead of our x's going +1, +1, +1, +1 every time, now there could be some skips or jumps, or they could go up by 2 every time or 5 every time. So now we have to kind of be a little bit more flexible on how we find those different changes. Okay, so that means our standards are all the same as they were last time. I can identify a linear function from a table of values. I can identify the rate of change for a linear function from a table of values, and I can find those missing values or extend a table using that information. All right, so let's look at an opener here today. All right, so now a new Tesla Model S costs $70,700. They offer a payment plan that requires a $6,000 down payment when you purchase the car. You also pay a monthly fee to work towards paying off the rest of the car. All right, so what I'd like you to do right now is go ahead and pause the video, fill out your notes, and answer those 4 questions, and then flip the video back on, and we'll see how you do. All right, so let's take a look. So if we look at our first change in x, we can see our month changed by 2. And if we look at our first change in y, it goes up by $2,100. Our next change in x goes up by 2 again. Well, how does our y change? By 2,100 again. So it looks like we're back in that ratio of 21 to 2, 21 to 2, or 2,100 to 2, I should say. All right, so it looks like we have that constant rate of change. Now, our next change of x is also 2. Well, it has to be constant, so that means I need that $2,100 change for y. If we add that on, we get that after 6 months, we've paid $12,300. Now, let's let's look at our final change in x here, which is 2 again. So I have to have that same change of $2,100 for y, and that means that after 8 months, we have paid $14,400. All right, so there it is. Now, we want to know what the monthly payment is. So notice we're not going up by 1 month here. We're going up by 2 months. So we have to look at that ratio and reduce it. So 2,100 divided by 2 is $1,150. So now, which of our four functions is this? It's got to be linear, and the reason is that constant rate of change. All right, so let's look at the next problem in your notes. Very, very similar problem, same idea, but we've given you a different table with different amounts. So once again, pause the video, check those answer those 4 questions, flip it back on, and we'll see how you do. All right, so let's take a look. So you can see this time that our first change of x, all right, when we go from month 0 to month 3, was 3. And our first change of y is $3,357. Our next change of x is 3 again. Well, guess what? Our change in y matches the first change of y, $3,357. All right, so we're back in that constant rate of change. Our next change of x is 3, so we have to have that same change in y of 3,357. Add that on to our $11,714, and we see that after 9 months, we have paid $15,071. And our final change, once again, is plus 3, which means our final change in y has to be the same as the previous. And we add that on to that amount. And we see that after 12 months or 1 year, you have paid $18,428. Now, once again, getting back to that monthly payment, all right, that's 1 month. We're going up by 3 months here. So we have to look at that ratio. And once again, 3,357 divided by 3, divide that out, reduce that fraction, and we get our monthly payment of $1,117. All right, so once again, it's got to be a linear function because we have that constant rate of change. All right, so now, if you flip your note sheet over, all right, so I have my note sheet here, right? All right, so we just did these 2 problems. We're going to flip it over, and we're going to fill out the top here. All right, so how do I determine a constant rate of change? Well, the first thing that you have to do, right, is find all those changes of x and all those changes in y, kind of like we did when we look back at that exploration, right? Look at those cells where I have both x and y, right? I'm going to find all those changes in x, changes in y, and then I have to look at all those ratios, right? So I'm going to take all my changes in y, put it over its corresponding change in x. And then we have to reduce those ratios. And if they all equal the same value, all right, then we know we have a constant rate of change. All right, so what we're going to do now is go through 3 different example problems to show you how we're going to combine yesterday and today, all right, into one big idea. So here's our first problem. All right, I'm just going to switch my side of the screen here so I don't block. All right, so let's go right back here. All right, so you guys can see the table there. All right, so now let's look at our table of values. So once again, we want to start looking at those changes in x, right? So we look at that first change of x, right? Goes up by 3. I don't have any changes in y to look at. My next x goes up by 3. My next change of x goes up by 3. All right, and we're missing those 3 y values there. So now we get to the information we know. So when I go from 6 to 9, x goes up by 3. And now when I look at my change in y, I go from 24 to 30, which is plus 6. Let's look at our next change of x. Once again, plus 3. All right, and my change in y here is plus 6. All right, now, so what we see is a constant rate of change, 6 to 3, 6 to 3. So every time x goes up by 3, y has to go up by 6. So when I go from 12 to 15, my x goes up by 3, so y has to go up by 6. 36 plus 6 is 42. Thank you, Jackie Robinson. All right, so now when I go from 15 to 18, all right, we go up by 3, so that means y has to go up by 6 again. 42 plus 6 is 48. So now let's go backwards now. So if we find those three values at the top of our table, all right, so now we know I have to go backwards. Now, the other thing I can see is that as I go up my table, my numbers are getting smaller. All right, so I should know that whatever number I get here has to be smaller than 24. So what number plus 6 is 24? 18. And then I have to work backwards again. So what number plus 6 is 18? 12. And then one more time, what number plus 6 is 12? And that would be 6. Now, what's our rate of change? It's a constant of 6 to 3 or 2 to 1. Either one is acceptable. And then we know it, that makes it a linear function. All right, so take a look at another example here. All right, so notice this time all of our information is at the bottom of the table. All right, we're trying to eventually work backwards and find out those first 4 values of y. Now, what I like to do is really just kind of go down the left side of my table and find all my changes in x to see if they're all going to be the same. All right, so if we look at this first one here, all right, we go up by 4. When I go from -5 to -1, I go up by 4. When I go from -1 to 3, I go up by 4. When I go from 3 to 7, up by 4. And then once again, we really want you writing these out to the left and the right of the table, writing these changes, because it's going to really help you see the pattern, all right, especially when you start looking at other functions besides linear functions in the next few lessons. So my next change is a +4. I get another +4. And I get another +4. Now, I typically like to just go ahead and do all my changes in x, because what this tells me is, right, is that, okay, all my x's change by the same amount. So if it is linear, that means all my y's are going to have to change by the same amount. So if I look at my first change of y from -9 to 3, it goes up by 12. So I look at my next change of y. 3 to 15 is also by 12. And 15 to 27 also increases by 12. So I can see I have that constant rate of 12. So every time x goes up by 4, y has to go up by 12. Now let's work it backwards. All right, not that backwards. There we go. All right, so now, all right, once again, if I'm going up my table here, I can see that my numbers have to get smaller. So I know this number has to be smaller than -9. So what number plus 12 is -9? -21. And then what number plus 12 is -21? -33. And then another plus 12 here. All right, so what number plus 12 is -33? -45. And then what number plus 12 is 45? -57. All right, so we have to kind of work it backwards there, all right, as we progress. So let's do one more together. Oh, let me finish this slide, I guess I should do. So our rate of change is, all right, 12 to 4 or 3 to 1 if we reduce it, and that makes it a linear function. All right, so one more together, all right, for this lesson. So now, you can see we're a little bit more sporadic here. We've got some jumps, some skips in the middle there, all right? And so we want to look at all those changes of x. So my first change of x from -9 to -6 is +3. All right, so now my next change of x is a +1. My next change of x is +2. My next change of x is from -3 to -1 is a +2. My next change of x is a +3. My next is a +1. And my final change of x is a +2. So I can see my x's are varying. So this is going to get back to kind of that idea of that exploration that I may have to look at some individual ratios and reduce them. So now the only 2 rows that I have right next to each other are those 2 middle rows. So let's look at that change of y. So notice when I go from 24 to 14, I go down by 10. So if I look at that ratio, that's -2 to, speech impediment, -10 to 2, which is -5. So now I need to confirm, okay, is this going to be constant? So now I've got to pick out 2 other cells that I know the information. So in this case, I'm going to look at -639 and -324. So when I go from -6 to -3, that goes up by 3. When I go from 39 to 24, that goes down by 15. And when I look at that ratio, -5 to 3, it is -5 as well. So that tells me that we do in fact have that rate of change that's going to be constant. Now because all the changes in my x are varying, that means I'm going to have to adjust my changes in y. So now let's go down to -114. All right, so now when I go from -1 to 2, my x goes up by 3. Well, if x goes up by 3, that means y has to go down by 15 like we saw from above. So 14 minus 15 would be -1. Now my next change of x, when I go from 2 to 3, it only goes up by 1. So now, when x goes up by 1, I need just negative 5. And then negative 1 minus 5 is negative 6. And my final change there is plus 2. So once again, I can see that first ratio. When x goes up by 2, y has to go down by 10. And then negative 6 minus 10 is negative 16. All right, so now let's go back up to negative 324 in our table and work backwards. So when I go from negative 5 to negative 3, x increased by 2, which means y should have gone down by 10. Now this time as I'm working up my table, my numbers are getting bigger. All right, so I can see that pattern, 14, 24, something, 39. So I had to have a number between 24 and 39. So what number minus 10 is 24? 34. Now once again, here's that self-check for us, because now, all right, when I go from negative 6 to negative 5 and went up by 1, that means y should have gone down by 5. 39 minus 5 is 34. Right on. Good work. We're on the right track. In our final change, all right, when we look at this, negative 9 to negative 6 was plus 3, so that means y should have decreased by 15. So what number minus 15 is 39? 54. All right, so that means we are finished for today. So now what you need to do is just hop on and do your Algebra 1, Algebra 1 Unit 1 Lesson 3 video check-in, all right, and then you'll work on the rest of this lesson on Monday. See you, my friends. Have a great weekend.